Welcome back to Humanless. I'm Leo, and today we're moving away from the creative side of AI to look at the digital plumbing that keeps our networks alive. We're talking WebRTC, browser nodes, and the grid it takes to build real-time communication.
It is a perfect follow-up to my latest track, Ghost in the Silicon. It got me thinking. We spend so much time obsessing over what data is being sent, but we completely ignore how it finds its way across the web. The connections themselves are a work of art.
And sometimes a work of absolute heartbreak. That is actually a quote from Anton, better known online as Meefik. He is a veteran engineer with over 20 years in software development and more than a decade spent entirely in the trenches of WebRTC. He launched an open-source framework called peerix because he noticed an exhausting trend. Even though WebRTC is a standard, building an app with it still feels like you're reinventing the wheel every single time.
Oh, it is the ultimate WebRTC boilerplate trap. You walk into a project thinking, I'm going to build a collaborative workspace or a fast-paced multiplayer game. But instead of coding your features, you spend 80% of your time wrestling with custom signaling channels, parsing complex ICE configurations, and manually managing brittle connection lifecycles.
Exactly. Peerix steps in and swallows all that friction by abstracting the madness into a single, elegant peer API. It is a client-side JavaScript and TypeScript library that runs entirely inside the browser. By keeping the heavy lifting local and decentralized, it locks in incredibly low latency, robust privacy, and zero server-side processing out of the box.
What really caught my eye is the underlying philosophy of the framework. It relies on a few really elegant fundamental pillars. First up, total transport agnosticism. A lot of traditional peer-to-peer libraries lock you into their specific custom WebSocket setup. Peerix essentially says, use whatever wire you already have laid down.
Right. It achieves this through a pluggable driver model. The driver completely separates the signaling transport from your core application logic. For instance, if you just want to test multiple peers locally on a single web page, you plug in the memory driver, want two browser tabs to talk to each other across the same machine without hitting the internet. Toss in the broadcast channel driver.
But when you are ready to scale to production, you can instantly drop in drivers for NATs, memqtt, socket.io, Supabase, or server-sent events. The application-level peer code stays identical. It legitimately unlocks a serverless P2P architecture if you use something like the NATs driver. Because the messaging infrastructure handles the peer discovery natively, developers don't have to write a single line of custom signaling glue code.
Right. But getting connected is only half the battle. What happens after the handshake is where the ideas behind peerix get masterfully precise. It implements something they call single connection multiplexing.
I call it digital minimalism. In typical WebRTC apps, if you want to stream multiple video feeds, audio tracks, and data streams, you often end up spinning up multiple separate peer connections or dealing with heavy renegotiations. Peerix funnels everything through one solitary pipe per peer. It massively cuts down on signaling chatter and preserves system resources.
Another core fundamental is extensibility through a modular add-on framework. The core API is kept intentionally minimal and lightweight. If you want advanced capabilities like recording media streams, local audio mixing, or syncing application state across peers, you don't bloat the engine. You just attach an add-on without touching your core features.
Now, to be fair to our engineering listeners, we should clarify the boundaries. Peerix is strictly client-to-client. It is not an SFU or an MCU. There is no cloud-hosted media server recording or mixing your video streams on a central cluster.
Exactly. It is intentionally designed for small to medium-sized topologies where you want to completely eliminate massive server bills and respect user privacy. You only rely on standard stun and turn servers for that initial NAT traversal to pierce through firewalls. Once that direct bridge is built, the server steps away entirely and the browser nodes communicate face-to-face.
It is an absolute win for the developer experience. It features an entirely zero dependency architecture. In an ecosystem where a basic app can pull down half of NPM, having something this lean, type-safe, and TypeScript first is a breath of fresh air. Plus, it is licensed under Apache 2.0, meaning it is completely unrestricted for commercial builds.
It genuinely lets you stop worrying about the plumbing, the collision negotiations, the ice gathering, the signaling overhead, and just lets you focus on building features.
Exactly. No tiers, just peers. Stop spending your week building the oven from scratch and just start baking your decentralized dreams.
Beautifully put, Maya. That is our dive into the fundamentals of peerix. Check out their codebase, and we'll catch you on the next node.
Bye-bye, dive safe.